Yeah, hello everyone. Thank you very much for the very nice introduction. Yeah, so today I'm going to talk a little bit about what FutureHouse is, well, how Edison relates to FutureHouse, a little bit of agent introduction, then a little bit about our agents and the latest kind of biggest release, which is Cosmos, and a little bit kind of an outlook also in the protein direction, what we're currently working on and what will be released soon. Yeah, like FutureHouse is yeah, it was founded in 2023. It's a non-profit, mainly funded by Eric Schmidt. It's based in San Francisco. And the focus of FutureHouse, especially after the spin-off from Edison, is the collaboration with academic labs. So there is also like grant programs, postdoc programs, and the idea is to kind of look more into basic research with the agent system Edison is then building. And Edison is our kind of the new startup based on it. It's the for-profit arm. So the idea is to kind of focus on the commercial applications of the agent system, and we're also based in San Francisco. Yeah, this is a little bit of the motivation. I know everyone knows that paper count goes up, right? Alpha count goes up. It's very hard to keep track of all the knowledge that is published, and this is kind of the main motivation also for the first agents like paper QA and our data analysis agent. But in the end, the issue is, yeah, as I mentioned, paper count goes up, data goes up, data is much cheaper to produce, everything is scaled up, and it's a little bit trickier to kind of find what you're looking for and also kind of get to more interesting discoveries, because those are also not, yeah, this goes also down. Yeah, and this is kind of the motivation for our mission. So we want to kind of accelerate scientific discovery, and give scientists tools to make your research easier. And we have a range of tools, but before that I will like super small motivation or super small explanation. Like we're working mainly on agents. We also train our models. And an agent is, yeah, in a very simplistic view, like an agent is usually a kind of a wrapped LLM to some degree. It is in an environment and it has some tools. And it can call tools, and this is like the simple example with a calculator environment. The agent has a calculation tool, triggers the calculation, gets it back, and then the answer that it got before, it can then answer that. So this is the very simple view. Of course, this is much more complicated, but this is kind of the simplest explanation. And we have a range of agents based on the kind of use case. I guess the literature one is the most prominent one. It's a deep research agent. It has several tools to kind of search, look for citations, look for the details. We have also one for proteins that uses several models to kind of help in the design process or in the task that is protein related. We have also one for molecules, where we also have a few tools, even like our reasoning model for small molecules. And then our data analysis agent is also kind of a very important part, because usually we work with big data amounts, and this is also needed. And this is here just like from an overview from the publication of our paper QA2 setup. So you see it's much more complex. We have like an input, we have an output. There has to be some managed state and all kinds of what comes with that running on our platform. So there's a lot of data processing going on in the background, making literature available, publications, patents, clinical trial data. So this is a big part of making that system perform properly and very good. And there's the paper search, I already mentioned that. There's like, we have a kind of a tooling that we call gather evidence that gets you then kind of the interesting passages to answer a question, and also citation traversal. And paper QA is also, you find it also on GitHub, and the one we kind of host on our platform is kind of a scaled up and a very, where also the data sources are kind of properly and coverage-wise very nicely implemented. And there will be also very soon a new revision of this tool, which will be even better than the one we currently use or ship. And here, this is like just to illustrate in a kind of way how the system works, right? You start out with a query, it's a text query, then the paper search is triggered, there is kind of, some stuff can be cached, some stuff can be local, some stuff needs to be scraped. Then the model kind of tries to get the paper together, looks into the details, then tries to kind of get to the stuff that is important to answer the question, and then at the end, it kind of synthesizes the answer, gives you all the references, so you can also track them down yourself, and that's kind of the way how it works in the background. If you look on our platform, you will not see those things, or there is a way to see also those details, but this is also kind of not necessary if you kind of, as an end user, to look at those things. Yeah, and here's like just an example from our publication where we were just like picking one example and kind of compared it to like our system and the baseline, or to a human baseline, to simply kind of verify that this is working, and simply with those knowledge retrieval tasks, the system is very powerful. Those systems also get a lot better over time, and it's a very like a useful tool, I think, in any deep research agent. Yes, we have also something that is also, I guess, very nice. We call it Has Anyone. Like if you want to look for something that you're not sure if it's already like was published or has been done, this is also a nice tool. And this is also, we use it quite often to verify if we have something, if the idea is really that new or if somebody has already tried it out. So this is also a very, very useful thing. Yeah, and I already mentioned, I mean, those things get better over time and will be cheaper over time. And I guess like a year ago, almost, the systems were very, at the early stage, but they're now really powerful. And I can highly recommend, if you're not using them for literature search, it's really like something that speeds up the process a lot and also kind of helps you to verify that you're not losing any important literature piece. Yeah, and here are just some numbers. So those numbers are also higher, I guess, by now. But in the end, the scale and the level of data processing behind the system is simply something that is hard to compete as a normal human being with just a browser, and this will continue. And this is kind of our kind of mission or the vision. Like, we want to create an AI scientist. We talked now a little bit about the red building block, which is the single agents, right? The literature agent, the data analysis agent, the protein design agent. And we have those kind of single tools at the bottom that can be, like what we talked before, search, specific deep learning models, databases, and all things like that. And kind of the latest addition to our kind of range of agents targets then this kind of AI scientist level in blue, and that's Cosmos. This is what I will also explain in a second. And the idea behind that is that you have like an agent that can trigger other agents, that has something like a world model, which helps it to reason about a specific topic. It can then create different hypotheses, different kind of ideas, tries to verify them with experiments that can be done in silico, or it proposes also kind of real experiments. And so the Cosmos is our AI scientist, and before we dig into the details, I guess the easiest thing is to have a look at the user interface. And the way Cosmos is currently set up is that you start out with a question. So it's a text input and a data set. And of course, those things should be related, and then Cosmos kind of triggers the agents, the literature agent, the data analysis agent, then to create a report that kind of, hopefully is answering your questions or surfacing very new, interesting questions. And this is also from the publication, and what you see here is that, like with this input, we have here also on the left kind of the question, then the data set, it's this point cloud, and then the system triggers a lot of kind of subtasks, gathers all the information from literature, runs data analysis scripts, and kind of runs a lot of visualizations. And then you get out discoveries. And this is all nicely formatted in a report. I will also, actually, I will show you in a couple of slides also how this output looks like in the actual system. But I guess the main question is always that we also get, right? This sounds all fancy, sounds all interesting, but how do you know this is helpful? And in our publication, we really worked with a lot of experts together. And we also use the system for our research, so it's sometimes really, really tricky. Like, you ask a question, you get 3 discoveries, and like I mean, there is always maybe one or two where you could say, okay, that's not going to be working out, but there are always a handful where you think that looks interesting, but I need some time and I need to check the literature myself if this is something that could be interesting to look into. So it's really at the edge of knowledge, and you really have to invest time, and this is why we work together with a lot of experts and kind of really to verify those things the system surfaced. And this is here a little bit about the kind of system setup itself. So we looked into a lot of things, but in the end, I guess one big factor is that simply you can save a lot of time, right? The system does a lot of the literature search, a lot of the data analysis, and then you can speed up your thing or your work with that. And this also scales a little bit. You know, scaling laws are everywhere in machine learning, and we also see here a clear trend. And we did a lot of also kind of benchmarking of the kind of base or the subsystem, the main system, and yeah, so it's looking all good, of course. And but let me now show you also a little bit from the publication. And the publication, like I have here just one example, but there are several ones in the publication. And how it's set up, how we set it up there is we always started with kind of a question related to a data set, and then we had kind of what Cosmos did, and then what the experts verified from the other side to kind of check, does that make sense? Is this a useful thing our system kind of carried out or not? And this is like then, how also Cosmos is then working on those things, on the queries, right? It does a lot of visualizations, so you got always a nice range of plots. They usually resemble also what you kind of see in the specific part, like in what is used in literature, and then tries to kind of validate its findings with the data. So sometimes data is easily available. We have also data sets on our platform. You can upload your data set, but sometimes it's also this, also the system comes up with kind of a very simplistic model and tries to model also relationships with kind of own assumptions. And yeah, then it tries to usually then derive some kind of insights, or in this case, like a mechanistic hypothesis, and then you get like a synthesis of the finding in a form of a text output. Yeah. In this case, in this case, then it was the human experts then sometimes also use like a different approach. But in what we could show in our publication is that this kind of the conclusions are then very similar, or even like have a very high degree of overlap. And this is like how the system looks. This is like on our platform, so this is actually what you can also look at on our webpage, and in the PDF publication, you find also all those links to those trajectories. And this is like then an output. You see the system creates a lot. Yeah? You have like a summary of what went into that. Then here is the interesting part where you have kind of the discoveries, can be 1, 2, 3, or even more. And then you always have like a little bit of a high-level summary and a little bit more sections with details, and this is how it looks like. So you really have plots with varying levels of complexity. The model tries a lot of things, and then you can scroll through them. So it really takes some time to also kind of go through the reports and check out what the system came up with. And then you can also look a little bit into the details. You see that all the tasks that run. So this is kind of what the net I have shown before with all the different literature search, data analysis tasks. We can open one where you also see kind of the reasoning of the model. You can look at the notebook. You can also download the notebook, rerun some parts yourself. Easily kind of switch to cells, see what the model has done. Recheck the objective, the data set, and all kinds of things. So it's it's a lot to explore. But I guess if you work on like what we also use it for very recently is like when we start new projects, we also trigger a few runs, see what it finds, like double check our assumptions, double check the assumptions of the system, check out, maybe find new literature that we haven't found yet before on our own, and things like that. So yeah, it's very interesting. A tool, I guess, for exploring kind of the possible space. And we have also, I already mentioned that we have a protein design environment, and what I talk about now is this environment that's currently on our platform, but there will be also soon an extension to Cosmos, so that Cosmos can trigger also more specialized protein design tools. And we support here, currently there are 5 deep learning models. The system supports ranging from molecular dynamics, bioinformatics, literature research, of course. And this is here just like from our current system, just to give you an overview what those tools look like, what the outputs look like, but this will be also soon in Cosmos available. So you have all kinds of protein binding tools, AlphaFold, diffusion models to kind of let the model access structure, get more information on the proteins, and this will be soon also available within Cosmos, that Cosmos then can also use those tools properly and design proteins. And there was a very recent competition where also somebody used already Cosmos without those fancy tools because they're not yet there, but it was also interesting to see, before we go, of course, in this study we also kind of then, we have also a wet lab, this was also validated and we also find something useful. But what I was talking about is this was like, I don't know, it's maybe 2 or 3 days old, it was posted on Twitter, but we found it very interesting at Edison. There's this NIPA binding competition and somebody just used their free Cosmos credits to run it through. Of course, as I mentioned, Cosmos has not yet the specialized tools, but Cosmos then tried to work around that, like tried to use maybe not the best tools, but still like made progress, was able to also kind of create a few proteins. I looked through them because I also am not an expert with an expert on our end. So some were very similar to known proteins, some were new. And to my understanding, this protein-based competition, then people can vote and then they will kind of verify that in some form in the lab. But I found it interesting. So this person also opened up these trajectories, you can look them up. I mean, don't expect that this output will be groundbreaking because the tools are maybe not there yet, but I guess with the next revision of Cosmos, where we have kind of the full range of the protein-related tools, this will be much more efficient, much more better. But it was super interesting to see that people are already using that. And this is here just from the competition, where you see kind of, the details the person put in. Here we got 4 discoveries, and so this was very interesting. But with the new release of the protein design tools, this should work should be lifted up to another level. Now a little bit about our platform. So when I talk about platform, we mean kind of our website where you can log in. We have if you log in the first time, you also have like a nice walkthrough. You get free credits. If you have like an academic Edu account, you get even more. We have also special grants for projects. So if you have something where you want to use our systems, reach out. And there's also an API, so you can easily call it from your own infrastructure, from a notebook, get more details of the literature runs and also Cosmos. And also for paper QA2, also most of the stuff is also public. And you can also run it locally. So this is also sometimes very nice to have and play around. We have also a very nice API, I already mentioned that. And like just as a side note, we actually also use that API in our own Cosmos setup, that Cosmos can also kind of investigate its own kind of work and benchmark itself. So this is really, can be quite interesting and useful. And please try Cosmos yourself and give feedback. For every kind of Edo account, you can run 6 free runs. And so please try it out. The standard cost is $200 simply because of all the system or all the stuff that gets triggered in the background. So it does a lot of API calls, it does a lot of scraping, data processing. And but you find it all on our platform.edisonscientific.com. And if you try it out and if you find something interesting or also not interesting, just let us know. And with that, I'm at the end of my presentation. So if you have any questions, I will be also around later, but thank you very much.
It's on, okay. This is so interesting, and I'm so excited to see where these agents are able to take biology in general. How would you guys ever consider making a publicly available data set where you've gone through, say, everything in PubMed and said kind of like based on our agent's reasoning, these claims, like this is how well these claims are like overstated versus not overstated given the data that's in the paper? You might make a lot of enemies, but I feel like that could be
Yeah.
a
Yeah.
super valuable resource.
I mean, in the Cosmos paper, there is one, we worked together with one group. I guess, I'm not sure which project it was exactly. They had their paper ready to publish, but it was not published, and then we kind of worked through it together. I mean, yesterday I was at also a presentation where this was discussed about machine learning. This is also something that we, I didn't mention that yet, but Cosmos will also have soon GPU support. So in theory, or not just in theory, you can then also run machine learning experiments. And yesterday in this discussion, the point was that the people actually thought having a system that could just, I don't know, take in an ML paper, replicate, and run it itself would be very valuable. And also, of course, replication would be the first step to extend. And I'm pretty sure, and a colleague of mine actually looked today up on LinkedIn that Hugging Face released something yesterday where they used also an data analysis agent to do that. And I'm pretty sure we will see that. I guess it's just, yeah, it will cost some money. And so I guess it will be more.
But I guess like even in the space of just wet lab results, of how good do you think it is at, say, like interpreting a gel and saying, I think that this gel agrees with what the authors claim or not?
That's a good thing. I guess we tried something, but I'm a little bit too far away from those colleagues.
Okay.
But that's an interesting question. I can ask like our science team.
Be super interesting. No, thank you.
Like,
There's some mics going around, yes.
Hi, thank you for the talk. My question would be, so right now you have kind of agents that work with a small number of tools. As you increase the number of protein design tools and even like just generally molecular design tools, what are your approaches for actually teaching these models how to work with this very large tool space and like large set of capabilities? Is it just like reinforcement learning on like, you know, like multi-step reasoning, or are there more complicated approaches? And also related to that, when you're working with like a really complex modality like protein structures, how do you actually get Cosmos or other future models to reason about these structures and perceive these structures in a way that human scientists would, as opposed to just relying on kind of descriptions of what the tools say they do?
Yeah, that's a very interesting question. We actually had a bigger journal club last week about kind of this, what's the current state of tool setups and how they are set up. And I guess there's now it seems there's a big move to go over kind of the software development kit code route. So you will have systems that I guess are very flexible by using code to kind of access all kinds of tools. So in the end, if your tool will be available in some form as an R or Python package, I guess this will be the future, that those models are very flexible in the sense that they will leverage code to use any potential tool that is in code form. For the second part, that the model perceives kind of biological modalities like a human being, I guess they're like what is sometimes easy for humans, like we like to look at pictures, right? When we see a molecule or a protein that is nicely rendered, we can easily build up intuition. I guess for LLMs that are text-based only, I guess I would say they have could be something similar going on, even just by inputting text. And there is also some work about, I don't know, in-context learning, where you show several variations of the same input, that the representation the model builds up is actually then capturing also the relationship in the data, even though the format is maybe not obviously intuitive to a human being. So I guess there are differences, and it looks like there is some work that points into a direction that this does not matter too much. I don't know, even if you would just put in the protein or the amino acid sequence. But yeah, I guess it also, the format is very important, right? Because if it's just the amino acid sequence, you will miss a lot of information, but there are ways around that to kind of enrich that even in text form.
Thank you. That's very interesting. I guess one thing that occurred to me is this would be quite a useful tool for people who want to use like paper mill style services. So have you considered, is it possible to like watermark the outputs, or either the visuals or even ideally the text as well, to decrease that sort of usage?
I guess the tricky part is, like, even if you could also recreate a lot of those plots, for example, from a screenshot. I guess it will be tricky to get 100%. And there are a lot of, I guess it will be tricky, to. That's true. Yeah. Yeah, but it's yeah something we think about it, but it's not easy. I guess it's the same like with, I don't know, image generation. I guess also didn't solve it yet. Although I have seen a lot of work about watermarking, and it's at this conference. But it's tricky, yeah, and it's potentially a very helpful tool for paper mills, yeah.
So along those lines, as you envision a future where AI and agents play a greater role in scientific discovery, what concerns or possibly scares you about that future?
I mean, I guess there will be change, right? But if you look back the last 10 years, there was already a lot of change. So, I mean, and change is never like, I mean, it happens, but maybe not. There's always a little bit of pushback, I guess. So I guess that, and I mean, also I have to say for my machine learning job, there's already a lot of change this year, right? I guess agentic coding went from barely usable to I use it every day. So there's also a big shift. Literature research tools, I guess, is also something I use now on a daily basis. That was not there a couple of months to that level. And yeah, I mean, there's a lot of discussions that you find on the internet, right? That I guess maybe some skills will be less valuable. I don't know, coding looks like those tools can do a lot of the work. And it will more shift to the idea generation phase and idea kind of classification phase. I guess this will be more important. I could imagine that a researcher that is very good with creating new ideas or looking at new ideas and saying this is good or bad, that this will be a very high leverage skill because then you have the tools at hand to make that happen much faster. Yeah.
Thank you so much for the talk. So I have a question on when this system, the product as is being launched in the enterprise environment where security settings may not permit the tool calling, outbound tool calling. Have you guys done any sort of study on degradation of the performance? And then the second question is that, do you guys, in the future roadmap, do you guys also plan to have connection to the physical system, so experimentation in an autonomous lab way?
Yeah. So for the first part, this is already solved. So we have customers that are already paying for the system or run it on their own infrastructure. For details, I can happily kind of forward you. But this is like we already do that. So there are companies that run the stuff on their end, on their system. The second question was again the. Yeah, that's a very good question. Actually, I also discussed it, I guess, 2 days ago. I'm not an expert with lab automation, but what I know is that I guess there's also like a big push to make a lot of the equipment kind of configurable via code or code-like structures, and I guess this will be the easiest interface, that you write some kind of configuration file or a piece of code that interfaces with the equipment, and then it is easy. I guess the issue is always like the connection. If the system somehow if you can feed or get the data out and get it into our system, it will work. I guess it's just the link is the problem, and I guess then it will depend. Do you have an older equipment that has an easier link, or a link where a human being needs to go with an USB stick from computer A to computer B in the worst case? But I guess that's solvable, yeah. And I hope that in the future it will be just like a tool or a skill. And you upload it there, and then it knows how to run experiments on your equipment. I mean, that's not like far away, right? If you can put that tool together, you can run it in an agent. Yeah.
Thank you so much, Michael. Let's give Michael a round of applause.
Thank you. Thank you.
So one small thing, we have a limited number of seats, and